Hello there guys, welcome back to another epic and execrable maths video. We're once again looking at matrices today, and for the very first time we're looking at something called the determinant of a matrix. We're only going to be working out what the determinant of a 2 by 2 matrix is today. We'll look at 3 by 3s and so on in future videos, but for now we're just looking at 2 by 2s. And many people say, before I even get into like what the formula is or whatever, because it's right there, I just want to say, for now, I'm not going to explain what the determinant really is. I won't do that in this video because it would take so long to explain and there's more building up that we need to do in order to get there. So there's no point in me trying to explain what it is right now. For now, the best way to kind of think about a determinant is just, it is a number that is associated with the matrix. And in the next video, which will be about finding the inverse of a 2 by 2 matrix, we will be using the determinant. But if you say, but what actually is the determinant? That will be in a few videos' time. It will get explained, okay? But for now, just think of it as a number associated with the matrix. So the determinant, if you have a 2 by 2 matrix, we call it M, let's say, that has elements A, B, C, D, the determinant of the matrix is just A multiplied by D minus B multiplied by C. A times D minus B times C. It's that simple. And just notation-wise, there's about 3 different ways that sometimes the determinant can be written. Some people write det M, like determinant of M. Some people put the matrix in the absolute value signs, like the modulus signs. And some people write the matrix again, but instead of using curved brackets, they use straight lines. So if you see a matrix with straight lines, typically that's going to mean the determinant of the matrix. I tend to write with this notation, but you can mix it up. So just so you know, all of those 3 definitions, all of those 3 ways of writing, they all mean the determinant of the matrix. Okay? So let's actually go through an example question of the determinant of a matrix. So we're going to come up with the matrix, let's do 6, 5, 1, 2. Okay, let's find the determinant of that matrix right there. Okay, how are we going to do that? Well, it's literally this simple. We notice that A, B, C, D, the determinant of this matrix, maybe I'll call the matrix A or something like that, just so that I can write det A. That's just going to be 6 times 2, which is 12, minus 1 times 5, which is 5, and 12 minus 5 is 7. Okay. So the determinant of this matrix, det A, is 7. So you see how we get a number out, we get a scalar, a normal number like the number 7 out, and this is just a number that is associated with the matrix, okay? Let's do another example. So here we have the matrix P, 10, 5, 2, 3. The question is to find the determinant of P. Maybe pause the video and have a think about what it would be. The determinant of P is going to be 10 times 3, subtract 2 times 5. Okay, that's going to be 30 minus 10. So the determinant of this matrix is 20. That is really all there is to it. Now I'm going to introduce a new word again that is associated with matrices, and that's the word singular. Okay, singular. So, if a matrix, let's say M, if M is what we call singular matrix, what that means is that the determinant of the matrix M is the number 0. Okay, so a matrix is singular if its determinant is 0. For the next video, just have this in mind, okay? If a matrix is singular, if it has a 0 determinant, it doesn't have an inverse. We've not looked at what an inverse is, but we'll look at that in the next video. But that's why we care whether a matrix is singular or not, because there's a special thing about matrices called the inverse of a matrix, and if a matrix doesn't have or if a matrix has 0 as its determinant, you don't have an inverse. You just can't do it. So that's why it's really important. So let's do a question regarding that. Okay guys, so here's a question. We get given the matrix A, which is 4p plus 2 minus 1, 3 minus p. And the question is, given that A is singular, find p. So remember, if a matrix is singular, its determinant is 0. So we should find the determinant of A and set it equal to 0 so that we can solve that for p. Okay, so the determinant of A is going to be 4 times 3 minus p. This is just using the formula here. Minus negative 1 times p plus 2. Let's simplify this. And by the way, this is equal to 0, I should write, because they say that it's singular. Okay, let's simplify and solve for p. 4 times 3 is 12. 4 times minus p is minus 4p. Minus 1 times minus 1, or right, this is just plus 1, right? So it says plus p plus 2 equals 0. Okay, like terms, let's gather them up. 12 plus 2 is 14. Minus 4p plus p is minus 3p. That's equal to 0. Add 3p to both sides. We have that 3p equals 14. So divide both sides by p. P is equal to 14 thirds. 14 over 3, like that. That's the answer. That's the answer. P is 14 thirds. So if P was 14 thirds in this question, the determinant of the matrix A would be 0. Okay guys, so I've got a two-part question for you right here. We have got a matrix B, which is this here, 3k, 4 minus k, k minus 2 minus k. That's a lot of k's. First part of the question is to find the determinant of B. And this is going to be in terms of k, okay? So the determinant of B is just going to be 3k times minus k, which is minus 3k squared. Subtract k minus 2 times 4 minus k. This is going to be equal to minus 3k squared minus, open bracket, let's expand. K times 4 is 4k. Outside, k times minus k is minus k squared. Inside, minus 2 times 4 is minus 8. And last, minus 2 times minus k is plus 2k. And we have minus 3k squared minus 4k. We're just distributing this negative out, getting rid of those brackets. Plus k squared plus 8 minus 2k. Gather up the like terms. Minus k squared plus k squared is minus 2k squared. Minus 4k minus 2k is minus 6k. And plus 8 is just plus 8. This is the answer. So the determinant of the matrix B is minus 2k squared minus 6k plus 8. The second part of the question is, given that B is singular, find the possible values of k. So again, I've just written up here, the determinant of B, we just worked this out, is minus 2k squared minus 6k plus 8. They now tell us that it's singular and to find the possible values of k. So there could be two values of k, technically, and it makes sense, it's a quadratic, could be two values that allow B to be singular. What does it mean if the matrix B is singular? Its determinant is 0. So we should set the determinant equal to 0. So minus 2k squared minus 6k plus 8 equals 0. This is a quadratic equation in terms of k. So you don't have to, you could just go and straight use the quadratic formula, whatever. I'm going to factorize it. So first of all, I'm going to divide both sides by minus 2 to get k squared plus 3k minus 4 equals 0. Then I'm going to factorize, because it factorizes nicely, to k plus 4 times k minus 1 equals 0. Okay, so that means that the two possible values of k are k is 1 and k is minus 4. And hopefully that makes sense why that's true. If you plug in minus 4, 0. If you plug in 1, 0. So those were some questions involving determinants of 2 by 2 matrices, and also the use of the word singular and what that means and how you actually use that in a question. So as always, guys, I hope that you found this video helpful, and I will see you in the next one. Cheers.